The views expressed in this interview are those of the individuals and do not reflect the official policy or position of the U.S. government, the Department of Defense, the U.S. Navy, or the Naval Postgraduate School. Welcome to the Trident Room, brewer of stout conversation, unfiltered and on tap. On today's episode, Trident Room host Luke Goorsky sits down with Kline and Lyla Englehorn.
They are leading the NWSI Warfare Innovation Continuum Workshop this year entitled Hybrid Force 2045. The goal of Hybrid Force 2045 is to understand how emerging technologies and operational concepts can be leveraged to build an effective future naval force. Now, before we dive into all that, can you just each introduce yourselves quickly for the listeners and share a little bit of your professional background, how you got to NPS, and how you got involved with NWSI? Captain, we can start with you.
Sure. I had 26 great years as a surface warfare officer in the Navy. Had 2 great commands. I came here in my final tour as the senior military faculty in the Operations Research Department. Had 4 great years there in uniform and then transitioned as a professor of practice in our Operations Research Department. During that time, for the last 15, 20 years, Lyla and I have been doing concept generation for emerging technologies, how to actually integrate them into Navy tactics. We've been looking at both the classified and unclassified issues with the threat emerging from China and new submarine threats emerging from Russia. And we combine our students in our classrooms and workshops in order to answer some of those problems. And it's been a great almost 15 years now here at MPS.
Awesome. And ma'am, how about yourself?
Well, thanks for having us and allowing us a chance to talk about all this work. I actually joined Jeff's team in 2011 with the start of the Consortium for Robotics and Unmanned Systems Education and Research Program, CRUISER. Mm-hmm. So we initially looked at problem spaces within the unmanned systems world and emerging technologies. And now with the Naval Warfare Studies Institute, we're looking at broader issues throughout the warfare spectrum. And I've been doing rapid concept generation using tools of user-centered design, sometimes known as design thinking, really focusing on the human in whatever problem space we're looking at. Mm-hmm. Within these wicked problems, very complex problem spaces, there is always a human you're solving for, regardless of the shiny tech.
Oh, yeah, and it sounds like, NPS is a great place for someone with that expertise or interest to come to. How'd you end up here at MPS or in Monterey?
That is a good question. I got my master's in public policy with Leon Panetta at the Panetta Institute for Public Policy, and part of my master's program was an internship. And I could do an internship in something I'd already been involved with or something brand new. And I had spent a long time professionally as an actor.
Okay.
And worked within the theater in a variety of realms: development, marketing, tech, lighting design. And I'd also worked in marine stewardship through the Monterey Bay Aquarium and Monterey Bay Aquarium Research Institute. I helped design the Deep exhibit for them. And so I could go back into that realm, and I decided to go brand new. I'd never worked in government. I'd never worked with the military. And I came and met with Jeff Kline, and he placed me on the Maritime Information Sharing Task Force to look at information sharing between government and industry, the public-private information sharing spectrum around port security issues. So that's what I did my thesis on.
Okay.
And when I got my master's degree, was lucky enough to join the cruiser program as it stood up, and Jeff was the director. And then now that he's the director, he started the Naval Warfare Studies Institute, I followed him to that program and continuing doing the same work.
Pushing him forward, right?
Well, that's not quite true. And what I mean that Lyla's made a name for herself on campus. Although her originally positioned in our maritime security efforts, when we stood up Cruiser, she had already set and became well known for her talent in bringing students together from diverse curriculum and services, and countries for that matter, to work on very hard problems. And so she is her independent person on campus. I just have learned to leverage her talents.
Yeah, and I think that the two of you here having you today is an awesome way to really demonstrate the unique, as we're going to talk about hybrid, but kind of the combination of different expertise areas that here at MPS, it allows to do some interesting, different, maybe out-of-the-box stuff that wouldn't happen at most military, more traditional military institutions.
Oh, absolutely. It is a very diverse academic environment. There's always fascinating projects going on, and it's almost an embarrassment of riches to be able to work with these ferociously intelligent people doing fascinating things and such a variety of research topics and problem spaces to work in.
Yeah, I like to say that MPS fills that orthogonal space between military culture and academia research. And so we're able to handle and cross those bridges quite well.
Mm-hmm. So let's dive right into Hybrid Force 2045. So I gave it a little bit of an introduction at the beginning, kind of taking my own words, but as the experts here, what would you guys say is the goal here?
Well, I want to back up a little bit and explain what we've been doing for the last 13 years or so. NPS has adopted a major theme of interest to the U.S. Navy. That's everything from distributed maritime operations to littoral operations in contested environments. Now, those two titles are well recognized by many of your Navy listeners, and Marine Corps listeners as current concepts. But we were working on them before they became current concepts, and so we like to leverage our tactically experienced and operationally experienced students while they're getting their educational degree to advance their professional knowledge as well, to help develop these new and emerging things to help inform the services. This year, we selected Hybrid Force 2045 specifically because it's in line with the Chief of Naval Operations' current strategy on developing a future force and the Commandant's strategy on force design. So we actually are in alignment with those strategic documents in order to explore exactly how you put it, to see what emerging technologies, what new concepts that we can employ or develop to employ in a future force. Because of the challenges that our adversaries have presented us now in both the competitive phase throughout all domains, whether it's space, whether it's cyber, whether it's conventional warfare, we now have to take a look at breaking up that carrier-centric force that we've served us so well for the last 70 years. We're entering the age of the robotic age of warfare with these emerging technologies, and we like to explore with you, the students, what that means for future warfighting and for future force structure. That's what Hybrid Force is all about. These warfare innovation continuums normally involve around 400 and 500 faculty, students, and sponsors in various activities. Lyla runs the Warfare Innovation Continuum Workshop that as soon as I stop talking, I'm going to hand the baton to her to describe. But we get our concepts and our ideas from that workshop, and then we spread that out across campus to various classrooms, to various research projects, thesis works in order to advance those ideas to see how promising they may be.
Awesome. So, yeah, do you want to dive into the workshop?
Oh,
That's
absolutely.
What you guys just did recently, correct?
Yes. End of September. I usually take the week between finals and graduation when students don't have classes so that you can be immersed in this complex problem space for 3.5 days with a facilitator and other students, as well as visiting engineers from academia and industry, the warfare centers. Very rich space for collaboration there. And one of the outcomes of these workshops is not just the concepts that then inform research and classroom projects throughout the year, but that intersection between junior officers and early career engineers. Some early career engineers in warfare centers, they arrived from their academic degree, they're sunk in their engineering specialty area and back in a lab space. And sometimes it's the first time they've met someone who's been operational out in the fleet in these battle spaces and using the stuff that they're developing. Sometimes it's the first time a student has met somebody from a warfare center who's designing the things they might use in the future. And it's a really important conversation to have and very important contacts to make as both of those individuals move forward in their careers.
Yeah, and I think that's one of the another key point that pointed out in some of the background materials you gave me on this was, it's really focusing on the junior officers and early career engineers, and I think that's a really good and important point to start making those connections. I think that, it gives you a little, I guess maybe JOs feel like they have a little bit more freedom to work outside the traditional boxes, and I think that perhaps the early career engineers have that a little bit as well. So maybe you get a little bit of increased creativity as you guys are going through this. Is that something you found?
Oh, yeah. Well, let's say you get an engineer from MIT or from Panama City or from Boeing. They just finished their degree, like Lyla described. They really love robotics. They have this really good idea. And then maybe we have one of our own officers who's going through the mechanical engineering department, and they've always been frustrated at something at the fleet, and they want to start thinking about and working on that as well. The synergy that occurs in those workshops is just fantastic. Now, we reap those ideas, and those ideas are what we like to mature. So that officer that stays here as a mechanical engineering student may work on some sort of crawler that they addressed in the workshop as a prototype demonstration for their thesis. Likewise, the MIT young faculty member or the young engineer or early career engineer that just came from Boeing can go back for an appreciation of how their ideas might be applied in the operational environment. And they end up advising their bosses, hey, this is an idea, but here's how to sell it, quote unquote, to a senior general or an admiral in order to put it in their language. So the synergy that occurs in the workshop are very powerful, both for future networks and for the ideas that come out of it. Not all the ideas we can use. Out of 100 ideas, 80 are looked at already or being currently researched, which is great. It means that everybody's been brought up to a common knowledge level. 10 of those ideas are fiscally or physically impossible. And that's great too, because it means you're pushing the box, you're pushing the boundaries, 10% nobody's thought of. They're going, when we go, wow, wait a minute, you could use that thing this way. And sometimes that's not emerging technology. Sometimes that's just a different application of a current technology that we wouldn't think about. And that's the definition of innovation.
There you go. That's awesome. So what are some of those ideas that you guys got out of the workshop this time around?
Well, I'll start with one, and then you can start
All
at a
right.
time.
You first.
Well, we were looking at this particular workshop at different emerging technologies and hybrid concepts. So one of the teams looked specifically at the ability for the undersea environment and benthic, the seabed, to actually contain different capabilities, rising payloads, so to speak, to employ at different levels throughout competition and warfare. So that you might have pre-positioned supplies around the world, pre-positioned oil, pre-positioned missiles, pre-positioned generators, so that those things can actually come up at times and locations when you actually need them. The concept of rising payloads is not new, but the process of putting it together as a system, its communication based on the political environment was different and new. And so there's some things about that system that still has to be looked at. It has to be, we don't want to build the entire system as a prototype, but maybe long-term effects of underwater storage of fuel, for example, and a rising payload. We haven't looked at that, what the effect of the fuel would be. Or should we, in fact, take a look at hydrogen generators underwater and then allow hydrogen fuel to be part of that total system? That was just one idea of the recent workshop. We also looked at some existing things that DARPA and ONR, Office of Naval Research, asked us to look at. The sea and surface wing and ground effect craft for potential logistics movement as well as rapid delivery of systems. And we looked at several other technologies. That's the other thing that comes into these workshops. We should back up a little bit, is that we invite both senior industry, ONR, DARPA, to come in and say, we got this widget, we got this thing, we got this platform. How would you use it in the operational environment? And so our students and our early career engineers that come, as well as fleet lieutenants, it's open not just to our students, but we also get officers from OpNav and from the fleet to participate as well. They'll struggle with those, and then they'll give a report. Here's how I would fit this in to the larger fleet.
And that's really interesting. And just kind of going on the SWIG idea for a minute, because I know I was involved in a war game the previous quarter with DARPA that was doing that. So I think it's really cool to kind of see, okay, went and did this war game, figured out some pieces that were of interest to DARPA, how it could be used, and then kind of giving it over to you all in your group and like, all right, let's find some more real-world applications for some of the stuff they figured out in the war game.
Well, in fact, that's by design. So you were actually the second step in a series of analysis that occurred with the SWIG. The first thing we normally do is we get an emerging technology from either industry or from DARPA or from ONR. We take that through modeling and simulation and campaign analysis to see what the impact would be. That's our first step. Or we take the technology that comes out of the workshop and we do that with it. Then we move it to the war game, the one that you participated in. We find out what are the strengths and weaknesses of both blue, how would red respond, if there is a green that is an ally, would they be susceptible or not? And then we move it to one other step, which is a massive modeling and simulation, which usually a student, an operations research student or a systems engineering student will take that piece of that concept with that emerging technology. They'll model and they'll simulate maybe 1 million to 500,000 engagements, varying the different parameters, different tactics. And then we use advanced statistics to understand what's important, how best to employ that system, how far that system has to go, how long its on-station time should be, how far that sonar has to look at in order to make a difference in those engagements. That informs then the physical design and prototyping of the equipment itself.
It's an awesome thing to be a part of here. I think it's really interesting, and hopefully we'll see the effects down the line. So beyond like the SWIG or some of those other things that Captain Kline talked about, what are some other things that you saw?
Well, there are beyond just technologies. Teams really struggle with like the full range of concepts. Some of them are organizational. Some of them, for this one in particular, have to do with force structure and design. So we gave them some inputs on what you need to consider when looking at force design. One of the teams came up with a 3-layered force design where they pulled the carrier out of the front and placed it in the back. So the initial force is a heterogeneous mix of unmanned, lightly manned, and manned systems working together for initial line defense. And there are intermediary vehicles that are connectors to the second layer, and then finally the third layer is the carrier in the back that is brought in when the threat is less to losing that high value asset. And that will have to be modeled to see how feasible it is and to identify the ideal mix of vessels. The team pulled a couple of vessels that were identified in the unmanned systems framework as example vessels, but now we'll have to do more work to flesh that out a little bit. Another team proposed a concept based on the idea in Frank Herbert's Ender's Game. Not Herbert. Anyway, Ender's Game. Herbert was Dune. I just watched Dune.
Yeah.
Dune on the mind. But in Ender's Game, there we go, Orson Scott Card. And looking at a human-machine team, how that human AI team works together, and a continuum of decision responsibilities. What decisions in what realms can be made predominantly at the machine level? What decisions need to be reserved for full human responsibility? And where are decisions that can be made along that continuum? And how does that decision continuum change in peacetime versus wartime? Looking at things like ethical decisions, which most likely remain in the human realm, versus system decisions and maintenance and logistics decisions, which could maybe rely more on machine decision making. So that's another concept that came out of this workshop.
And associated with that, which I found interesting, was human in the loop machine learning. So interestingly enough, and since that workshop, I thought it was amazing. It was an aha moment for me, right? So, and of course, for our statisticians who are working on machine learning, it was like, okay, that you use databases to train machines, essentially. But what I found out, and later, in fact, in a podcast very similar to this, was that the original machine learning was human in the loop. And the fact that they were training machines to recognize cats, a photo of a cat, for example, by having humans respond to what that was to the machine. That is, the machine asked the question, the human answered the question, and the machine then collected that data at the same time that it was actually learning. So it was kind of an interesting concept to go back to the future, so to speak. The other big concept that came out of that Lyla just mentioned was that forward force, that's heterogeneous, small robotics force that's forward in offense, implies that we need to procure, design, and employ systems as a system, not platforms. And the Navy is a little bit off axis on that right now. We have 3 different DEVRONs for unmanned systems, undersea, surface, and air. We have NAV-C and NAV-Air, which are working on separate unmanned platforms. We're essentially building unmanned platforms as extensions to manned platforms. That's okay, but the real power will be when they're built as a system against a particular mission, and we develop an organization. When that's what this team implied. We developed an organization that actually builds a system, a multi-domain unmanned system response to a particular mission, not stovepiped. And I think we've got a ways to go for that as a Navy, but it's a great message. When lieutenants get involved with that decision, they someday are the commanders and captains that make it happen.
Right, yeah, and I think that's going to be really one of the big takeaways here is, or one of the big buy-ins for a lot of these lieutenants here is, what do I need when I'm going to be in charge of a ship? And, especially worst case scenario, missiles are being fired, right? You're going to want to make sure that all these questions have been answered, thought of. You're going into war with the best technology that's there. So I think it's great that all these conversations are really happening. And just to kind of go into the carrier model that you guys were all doing. Again, tying it back to the whole MPS community here, I had Professor Wirtz on this podcast maybe a month or 2 ago, and we talked about a very similar thing from his proceedings article, basically talking about the sea control versus sea denial force. So it looks like you all basically, took in that his wasn't necessarily a unique idea, but kind of expanding on that idea, and then you all kind of running with that forward again, kind of displaying some of that innovation or the iterative steps that can occur here at MPS to really help inform warfighters in the future.
Absolutely. And each year we base the warfare innovation continuum within a scenario, near peer, near future, just below conflict scenario that Jeff Kline creates from his knowledge of the space and ripped from the headlines, and creates a completely fictional scenario, completely open source. And we present that as a scene setter for the students to imagine yourself in this future environment as you're commanding a squadron, a fleet, a carrier strike group. What would you like to have available to you in this future scenario? They don't have to keep all the pieces of the scenario or address everything in the scenario, but it allows them, it helps place them in that future place where they might have a need, and from their operational experience they get to then create that whatever they might need.
Yeah, and I think that, like you said, when you're kind of placing these 3 days in between quarters here, and kind of you really get the students can really get immersed in it and kind of not have to worry about other classes going on and things like that.
And I should be clear, that's just the workshop, that 3.5 days. That same scenario is then used in different courses throughout the year that the continuum extends over. It is used, for instance, as the systems engineering analysis capstone project. That's the scenario they use to address their tasking.
Joint campaign analysis classes, Navy tactical analysis class, the tactical oceanography class uses it. The energy logistics class uses it. Those are all I could keep listing them, but it'd be boring. They're the capstone courses in many cases in the curricula that use that scenario to help inspire whatever their problem is and what they're going to be working on. And we produce that every year. We've got, 10, 12 scenarios now. Some are out of date because the future that they predicted is already passed, so to speak. But But then we also have those scenarios are used at times by the Naval War College as well, and Marine Corps University, to be able to lay the backdrop to get people to thinking about how to actually employ the weapon systems they may have to design and use.
Thanks for joining us in the Trident Room. For more information about today's guests and topics, please visit the show notes. The Trident Room has been brought to you by the Naval Postgraduate School Alumni Association and Foundation. For questions, comments, and suggestions, please email us at tridentroompodcasthost@nps.edu and find us online at nps.edu/Trident Room Podcast.